So sometimes when you look at a number, you might not know what it divides to right off the bat. So in this case, I have 117. Look at your prime numbers. Start with the lowest and work your way up. Is 117 divisible by 2? You know the answer to that is no, because this is an odd number. Try your next prime number. Is 117 divisible by 3? Yes, it is. You know that 3 times 39 is 117. So those are two factors. Are either of those prime? Yes, this one is. Now you have 39. Some of you might know what that breaks down to, and some of you might not. So again, is it divisible by 2? No, because it ends in an odd number. Is it divisible by 3? Let's see. 39 divided by 3 is 13. So we know 39 breaks down to 3 and 13. Are those prime? Yes. And that was actually a really quick one. So put them under your radical. Circle your pairs. At this point, you should know when you have a circle, cross it off, and one of the numbers comes out. In this case, we have a 3 on the outside, a 13 on the inside or under the radical, and this is my answer. You can always check it to make sure you are right. So now let's up the ante a little bit. Say we have 1,183. So right off the bat, we know it's not divisible by 2. Let's check to see if it's divisible by 3. It is not. Will it be divisible by 5? No, because if you look at the last number, it does not end in a 0 or a 5. Why don't we try 7? 7 works. 7 and 169. We know 7 is prime, so circle it. Some of you may or may not know 169 is a perfect square, so you know what it should break down to. But if you didn't, this is your thought process. Is 169 divisible by 2? No, it's an odd number. Is 169 divisible by 3? Nope, you get a decimal. You know it's not going to be divisible by 5. What about 7? Nope. What about 11? Nope. Oh my gosh, what about 13? Yeah, 13 times 13. Which are both prime. Look at that, nice and short. Circle your pairs. Cross off a circle, bring one out. You have 13 on the outside of the radical, 7 underneath. So this is your simplified radical. When you put them in the calculator, they will match. So now there are just some special cases that are super nice and quick. Say you have a perfect square, but you forget that it's perfect and you start breaking it down. So in the best case scenario, you'd say, oh, the square root of 36 is 6. But in case you don't do that, you might start breaking it down. And I'm going to go quick on this. You get 12 and 3, 4 and 3, 2 and 2. This is what it's going to look like by the radical. You're going to have your numbers, circle your pairs, cross out a circle, pull a number out. 3 times 3 is 9. Square root of 9 is 3. This goes to 6 on the outside. And notice how nothing is left on the inside. So your answer is just 6. Keep in mind, you do not want to do all this work. You should be able to look at this and say it equals 6. But just in case you don't, this is what it's going to look like when you get to this side. And one last quick example. Square root of 21. You know, 3 times 7 is 21. They're both prime. So when you put it under the radical, notice how there's no pairs. So all you do is you multiply back together, and it turns out this cannot be simplified anymore.